Good afternoon. My name is Mark Stewart. I'm Director at RSK Geosciences, and I'd like to welcome you to our first webinar in the Down to Earth series of events, which we hope you're going to find enlightening and entertaining. First, I'd like to go through a bit of brief housekeeping. Thanks, Viv. So all microphones and webcams are automatically turned off. So unfortunately, we're not going to be able to hear or see you today, but we'd still like to hear from you. So please, can you post any questions you have in the questions box, and we'll answer as many as we can at the end of Vivian's presentation. Those that aren't answered, Vivian or someone from the team will get back to you by email. Shortly after the webinar ends, you'll receive a link to a short survey. So if you could take a few minutes to complete it to help us to improve on future webinars, that'd be very much appreciated. You can also suggest any topics you'd like to hear about in the future. So without further ado, I'd like to introduce our speaker this afternoon, our Associate Director, Vivian Dent. Vivian is a contaminant hydrogeologist with 25 years experience in the industry. She is the technical lead at RSK for sustainability appraisals for remediation, and is a member of the Sustainable Remediation Steering Group at SURF UK. She's also the current chair-elect of the Association of Geotechnical and Geoenvironmental Specialists, the AGS. Her talk this afternoon is entitled Sustainable Risk Assessment and Remediation. So over to Vivian.
Lovely, thank you, Mark. I'm going to turn off my webcam too, so that you can concentrate on the presentation, and I'd just like to thank you for joining. So the aim of the presentation is to demonstrate through a series of case studies how appropriate risk assessment can be utilised to provide a more sustainable development, and how optimum remedial solutions can be chosen utilising the SURF UK framework, a recognised method of assessing the environmental, social and economic impacts and benefits of a variety of remedial techniques. The presentation will look at why should we incorporating sustainability considerations into a project. It will then provide a brief overview of what our risk assessors do, and I'll explain what SURF UK is and how it's used. Then there are going to be a number of case studies demonstrating the application. So when I was putting this presentation together, I did some research into the construction industry, and this is what I found. According to the Construction Leadership Council and the Green Construction Board, the construction industry generates 63% of waste in England. That's from demolition, construction, excavation waste and dredging. And according to the Waste and Resources Action Programme, WRAP, 32% of landfill waste is generated by the industry. Such schemes such as WRAP and the DALCOP have led to reductions of waste sent to landfill. However, according to the Construction Leadership Council and the Green Construction Board, 5 million tonnes of construction and demolition waste and 26 million tonnes of excavation waste are sent to landfill. If we take a look at resources, the Construction Leadership Council and the Green Construction Board report that the construction sector is the largest user of materials in the UK. In 2008, a BRE project reported some 380 million tonnes of resources are used by the construction industry each year. Climate change. So the UK has signed up to achieve net zero by 2050. If we're going to achieve this target, we're all going to have to reduce our CO2 emissions. According to the International Energy Agency, buildings and construction sector accounted for 39% of energy and process-related carbon dioxide emissions in 2018. And there are also other issues such as loss of biodiversity, which are big issues for the construction industry, but I'm not going to go into detail. So why incorporate sustainability into a project? We have planning policy and guidance which support sustainable developments. Within the context of contaminated land, the National Planning Policy Framework, NPPF, statutory guidance published in February 29 states in Chapter 2, at the heart of the NPPF is a presumption in favour of sustainable development. And the recently updated Environment Agency's guidance, Land Contamination Risk Management, known as LCRM, supports sustainability considerations throughout the land contamination risk assessment process. We're going to have a quick look at risk assessment and the kind of work that our assessors are involved in. The presentation is focused on human health and groundwater and surface water, but we also have ground gas risk assessors. Our risk assessors can derive both generic assessment criteria and site-specific assessment criteria, incorporating multiple exposure pathways for a variety of land use types. We're experienced in the use of UK, European and international risk assessment models such as Clear Risk, Rebecca and S-Risk. We have experience in modelling metals, inorganics, petroleum and chlorinated hydrocarbons. We can undertake refinement of soil assessment criteria to take account of bioaccessibility, specifically for arsenic, cadmium and lead. And we can undertake site-specific risk assessments for asbestos in soil. With respect to fate and transport modelling, our risk assessors have expertise in a variety of models, UK, US and in-house models for detailed controlled waters risk assessment. We undertake detailed quantitative risk assessment for a variety of reasons, including risk assessment for environmental permitting, development of brownfield sites, sustainable urban drainage schemes, the derivation of site-specific soil and groundwater assessment criteria for use as remedial targets. We have extensive experience of reducing conservatism in controlled waters exposure modelling. We also have an in-house tool for modelling the fate and transport of non-aqueous phase liquids, such as petrol and diesel. On to remediation. We tend to think of remediation as being beneficial, but is it? Remediation seeks to reduce risks associated with soil and groundwater contamination, but it also uses energy, it uses natural resources, it can generate wastes, and it can introduce health and safety risks. The key issue is that remediation is not sustainable per se, and certain strategies and technologies may actually cause more damage than they solve. So what is sustainable remediation? The Sustainable Remediation Forum, SURF UK, define it as the practice of demonstrating in terms of environmental, economic and social indicators that the benefit of undertaking remediation is greater than its impact, and that the optimum remediation solution is selected through the use of a balanced decision-making process. In the following few slides, I'm going to give you a brief overview of the SURF UK framework, which can be used to assess the most sustainable remedial option for a site. Why use SURF UK? Why is it appropriate? So the NPPF statutory guidance requires there to be a net benefit of intervening with respect to social, environmental and economic impacts. The EA LCRM notes it's important to consider a sustainable approach to remediation and signposts SURF UK. SURF suggests a number of categories and indicators to evaluate the social, economic and environmental impacts, which can be both positive and negative. It's a recognised framework to enable consistency, it's accepted by regulators, and it's flexible and it can be tailored to project requirements. There are 6 key principles behind the use of SURF. The first one, protection of human health and the environment. So remediation should be a site-specific risk management, removing unacceptable risks to human health and the environment now and for the agreed future land use, if that is different. It should be safe. There should be safe working practices, both for the workers and for local communities. There should be consistent, clear and reproducible decision making, record keeping and transparent reporting. So always assumptions and uncertainties should be considered in the project. There should be good governance and stakeholder involvement, and it should be based on sound science. It should be based on relevant and accurate data, clearly explained assumptions, uncertainties, and professional judgment. There are a number of requirements of SURF UK. The key requirements are to identify the relevant stakeholders. That could be the landowner, the local authority, the environment agency, the tenant. You should identify the boundaries to the project. This could be the physical boundaries of the site. It could be timescales. It could be the life cycle of the remedial works. For example, energy use. Are you going to consider only the energy used in the site for remediation, or are you going to consider manufacturing the equipment as well? It should identify categories and indicators, and we're going to consider these in the following 2 slides. And the assessment can be qualitative, so it doesn't include any metrics. For example, you could compare your remedial options by using descriptors such as equal, better, or worse. It could be semi-quantitative, a system whereby the categories and the indicators you choose are scored. And I'm going to be giving an example later of a semi-quantitative system whereby the severity and longevity of impact is scored between 1 to 9, as shown in the slide. Impacts are either positive or negative. And when using a semi-quantitative system, it's important to define the scoring system. For example, if you look at the slide, we've got minor, medium, high, and critical impacts. An example of a minor environmental impact could be discharge of a contaminant to a stream below the relevant environmental quality standards for that receptor, whereas the critical environmental impact could be discharge to a stream resulting in the death of ecosystems within that receptor. So it should be clearly defined within your assessment. And then finally, the assessment can also be quantitative. This could be a cost-benefit analysis of a specific aspect of the remediation. For example, the cost of remediation per carbon dioxide emitted. Fully quantitative assessments are very rarely undertaken because you rarely have enough information. So looking further at the categories used in the assessment, looking at the slide, for each pillar of sustainability, that's economic, environmental, and social, there are 5 categories. If we look at the environmental pillar, you can see that the categories are emissions to air, soil and ground conditions, groundwater and surface water, ecology, and natural resources and waste. And for each category, there are a number of indicators. For example, for the economic pillar, looking at the employment and employment capital category, indicators include job creation, employment levels, short and long term, skill levels before and after, opportunities for education and training, innovation and new skills. Now that I've given an overview of risk assessment and SURF UK, we'll look at some case studies. Case study 1 is the site of a former plating works on an industrial estate. So chlorinated solvents had been encountered in soils, groundwater and vapour in the area of the former plating room. The site had been investigated previously by a different consultant, and that consultant had advised the client that remediation was required to manage vapour intrusion risks. The costs of this remediation were going to be in the region of £500,000. RSK reviewed the available information and assessed the data with respect to RSK's generic assessment criteria. And we concluded that remediation with respect to vapour risks was unlikely to be required, thus already, without doing much work at all, saving the client hundreds of thousands of pounds. RSK's review determined that the only potentially complete pollutant linkage was continued migration of chlorinated solvents within groundwater to a wider secondary aquifer. A number of data gaps were identified within the existing assessment, including uncertainty in the hydraulic gradient, the natural attenuation parameters hadn't been monitored, there was the potential preferential pathways which hadn't been investigated, such as integrity of drainage was unknown, and the continuity of an underlying cohesive layer was unknown. RSK scoped further investigation to address these data gaps to better inform the groundwater risk assessment. The resulting risk assessment identified that the contaminant plume in the secondary aquifer might extend to approximately 75 metres. Discussions were held with the regulators, and it was agreed that a remedial options appraisal would be undertaken to aid risk-based decision-making. In line with the then CLR 11, it's now LCRM, remedial objectives were set to reduce contaminant mass in the source zone and consequently to reduce contaminant mass in the aquifer, ideally such that water quality standards were met 50 metres from the property boundary. It was noted that this was going to be extremely difficult owing to the permeable nature of strata, which didn't allow much time for degradation processes to occur. The project needed to be completed quickly, it needed to be economically viable, it needed to be completed while the building remained operational, and it needed to minimise disruption to the local community. Technically viable options were determined as shown in the slide, and then further assessed for their speed, economic cost, regulatory acceptance, technical viability of implementation, together with the advantages and disadvantages. And this assessment provided a short list of options for costing purposes that were practically viable for implementation at the property, either in isolation or in conjunction with other methods. The two shortlisted options comprised localised excavation and enhanced in situ bioremediation. And the second option was installation of in situ chemical reduction, that's carbon impregnated with iron. However, at this point, it was considered that the net benefits of intervening to undertake the remediation may not clearly outweigh the cost of doing so. This was primarily the economic cost. So the cost of remediation was going to be in the region of £200,000 to £360,000, and that excluded legal fees and lost revenues. And that was as opposed to the land value, which was about £600,000, the low aquifer sensitivity and the distance to the receptor and the occupied nature of the site. Hence, it was agreed with the regulators that SURF UK would be utilised. A SURF UK semi-quantitative assessment was conducted from the viewpoint of the client. It should be noted that sensitivity analysis should always be conducted, as the client might have differing views as to how important categories are compared to other stakeholders, particularly economic cost. The stakeholders identified for the project were the client, the Environment Agency, the local community, both the industrial neighbours and nearby residents, and the local authority. The boundaries of assessment considered. So we looked at the mobilisation of the equipment to site, but we didn't include the manufacture of equipment. There needed to be access to the building during the works, and the building should remain post-remediation. So if you now look at the slide, from the client's perspective, that's the results at the top. The assessment shows that all three options enhance the environment, with source excavation and enhanced M&A scoring the lowest. This is a result of the potential for emissions and odours during excavation, combined with the off-site disposal of soil from the source area. The no further action option scores higher than the two remedial options, owing to the economic cost of implementing the remedial systems. Socially, all three come out as negative impacts. This is a result of the no further action not upholding the polluter pays principle. And for the two remedial options, the source excavation scores more negatively, owing to the additional impact to the neighbourhood and site staff safety issues associated with the excavated material. So this assessment actually indicates that no further action based on the existing risk assessment is the most sustainable way forward, mainly based on health and safety implications, impacts of waste disposal, and cost of the other remedial options. The social negative impact for the no further action option is a result of the polluter pays principle not being upheld. So at this point, a sensitivity analysis was undertaken, and we did the sustainability assessment from the viewpoint of the Environment Agency. Now we'd weighted some parameters within within the assessment. So from the EA's perspective, we reduced the economic cost ranking and the employment ranking and the induced economic benefit. In addition, the ranking of impact to groundwater and surface water was increased and the impact on air was decreased. Taking these revisions on board, the outcome is amended such that the three options are more similar with respect to the sustainability outcome. RSK concluded that the benefit of undertaking remediation did not outweigh the no further action option. This decision is clear-cut with respect from the client's view, owing primarily to direct economic ranking, but it's less clear when other stakeholder views are considered in isolation. However, further monitoring indicated that the plume was stable, and given the operational source was physically removed following cessation of manufacturing processes, it was subsequently agreed with the Environment Agency that it was not sustainable to undertake active remediation of the underlying soil and groundwater. So, in conclusion, the outcome of the risk assessment, the SURF UK risk assessment and the regulatory liaison was that remediation was not required, which provided benefits such as emissions and negative effects that would have occurred as a result of the remediation were avoided. Resources weren't required for the remediation, no waste was generated, and there were substantial cost savings for the client. For case study 2, we're going to look at the Grassmoor colliery project. This site in Chesterfield is on land having a series of lagoons that have formed within spoil tips associated with the extensive workings of the former Grassmoor colliery, which opened on the site from the 1840s until its closure in 1967. The lagoons were historically used to treat effluent from the former Grassmoor gasworks and coking plant. After the decline and eventual demolition of the Grassmoor coking plant, the lagoons continued to treat effluent from the nearby Avenue coking plant. The former Grassmoor coking plant and colliery were reclaimed in the 1970s and now form part of the Grassmoor Country Park. However, the lagoons and spoil tips remained in situ, surrounded by and isolated from the surrounding country park and the adjacent Grassmoor Golf Club. The Avenue coking works closed in 1993, and when Derbyshire County Council acquired the Grassmoor land, it was discovered that over 50,000 metres cubed of coal tar sludge had settled in the lagoons, so the area had to be fenced off to prevent public access. The contents and steep sides of the tar lagoons made this site dangerous. The desire of the local authority was to remediate the site so that it formed part of the country park rather than fencing the site off. Remediation to generic assessment criteria was not going to be feasible or sustainable. Therefore, site-specific risk assessments with respect to human health and controlled waters was conducted. With respect to human health, RSK engaged in a scheme of extensive stakeholder engagement, which resulted in 100 questionnaires being completed. The results of the survey indicated that the general public use the site a lot for walking their dogs. The survey provided RSK with data on the duration and frequency of visits, together with the age groups visiting the site, enabling the CLEAR model to be populated with site-specific information. In addition, bioaccessibility testing for arsenic was undertaken, the results of which ruled out arsenic as being the driver for remediation with respect to human health. And in parallel, site-specific remedial targets for controlled waters were derived using site-specific data collected for the site, including hydraulic conductivity testing, hydraulic gradient, direction of groundwater flow, and the redox conditions in the aquifer to demonstrate degradation rates in groundwater. The CSM for controlled waters identified that there was a complete pollutant linkages between contamination in groundwater beneath the site and the site's adjacent brook. Both human health and controlled waters remedial targets were combined, which, when achieved, would allow the site to be restored to use. The remedial options appraisal conducted for the site needed to provide a robust solution for tar treatment in the lagoons that is proven to be effective and durable and will not require working or maintenance. It needed to meet site-specific risk-based target concentrations to allow reuse of the material as far as practical to minimise off-site disposal. The project needed to be delivered quickly so it could be reopened as a local amenity, and also there was funding which had a timescale attached to it. We had to ensure that there were minimal costs for maintenance following remediation and minimise short-term environmental impacts such as odours and traffic, minimise restrictions on the end use for the park, and it had to be affordable to the funders. So 2 feasible options were identified following the assessment of relevant options, those being excavation and disposal to an appropriate licensed facility, and the other option, windrow turning combined with a cover system. That was going to be mixing sludge from the colliery shale, moving it to an ex situ treatment bed where nutrients were added to increase biological processes. In this case, a very simple assessment looking at the economic costs, benefits and sustainability of these 2 options was considered by ranking items from 1 to 7, with 7 being the most desirable. The most desirable, or the most sustainable primary remedial treatment technique, windrow turning and a cover system, was selected on the basis of these results. So this technique involves using the on-site colliery shale to facilitate the bioremediation of the most mobile and harmful organic contaminants within the tars. The shale and tar mixture is turned regularly with a large mechanical windrow turner to encourage the process. When the treated material complies with the site-specific target values, it's reused to create new landscaping features. Thus, material is prevented from being sent to landfill. So the images on the slide show the remediation in progress. Remediation is now complete and the site now forms part of the wider park. Okay, for case study 3, we're going to look at a non-aqueous phase assessment. On this site, approximately 1,000 litres of oil had been lost to ground. Remedial works had been undertaken. However, it was reported that approximately 600 litres of residual contamination remained in the ground. The site had been identified as being located in a Zone 1 source protection zone associated with a public water supply abstraction point 500 metres to the east of the subject site. The depth to groundwater was reported to range between 11 to 25 metres below ground level. The Environment Agency required further assessment to provide assurance that the residual oil did not present a risk to controlled waters. Now, this site had a relatively large unsaturated zone, and in order to assess the potential for NAPL to migrate through the unsaturated zone, NAPL calculations were undertaken to predict how the resulting residual NAPL might migrate vertically and whether the oil would actually reach the water table. In-house calculations were used for the assessment, together with a comparison against published nomographs. Nomographs are charts which predict the migration of NAPL and therefore a variety of soil types. We use those as a second line of evidence. The results of the assessment predicted that NAPL would migrate up to 6 metres and that any residual contamination was likely to be immobile. So the sustainability gains for this project were that a desk-based assessment was conducted without the need for intrusive investigation. The assessment concluded that NAPL was unlikely to reach the water table and therefore residual contamination was unlikely to impact the public supply well. This reduced the client's liability and the conclusion was that further remediation was unlikely to be required. Case study 4 looks at an example of how the derivation of GAC's generic assessment criteria for specific land uses has led to a reduction in the conservatism in the contamination assessment. So the risk assessment team realised that RSK were investigating a number of primary and secondary school sites. The conceptual site model for a school doesn't fit with any of the clear model end uses. Therefore, in order to be conservative, GACs for residential without plant uptake were being used for the contamination assessment. We therefore decided to derive in-house GAC for both primary and secondary school sites. Looking at the table, the first column shows the residential with and without plant uptake generic assessment criteria. The next column shows the primary school GAC. you can see that the primary school GAC are much higher than the residential with and without private garden GAC, which therefore results in a less conservative assessment and ultimately less remedial works being conducted on the sites we were investigating. More recently, we've also derived a set of remedial targets for residential development with gardens for material being placed greater than 0.45 metres below ground level. So, for example, beneath the clean capping layer that's often incorporated into domestic gardens and landscaping. These GAC provide further justification for the retention of soils containing metals exceeding the residential GAC, where they're used beneath the capping layer or hard standing. This increases the potential for reuse of soils on site. The NR in the table is not relevant because the pathway is broken. With respect to the volatile compounds, benzene and naphthalene, the GAC remains low due to the vapour pathway, although the plant uptake pathway is removed. So for end uses which don't fit any of the conceptual site models for existing GAC, RSK can develop a generic assessment criteria. Other examples might include care homes, fast food restaurants, supermarkets. Ultimately, this is likely to result in more sustainable assessment criteria, although I should stress that in some cases, assessment criteria could decrease. So, conclusions. DQRA can be used to refine the site's conceptual site model and hence reduce conservatism in the assessments, therefore resulting in more sustainable decisions. In some cases, DQRA can conclude that there are no potentially pollutant linkages, therefore remediation is not required. DQRA can be used to derive achievable remedial target concentrations, therefore increasing the likelihood of remediation being successful and ultimately more sustainable. SURF UK can be used in the remedial options appraisal stage to determine the most sustainable remedial technique. And generic assessment criteria can be derived for non-standard end uses, often resulting in less conservative criteria. And thank you for listening.
Thank you, Viv. That was great. So we've got some time now for some questions and answers. I've got a few questions coming in. First one, Viv, is how do the UN Sustainable Development Goals relate to the SURF framework, and is there a direct correlation?
So actually, SURF UK recently published an update to the original document where we've linked the SURF UK framework to the UN SDGs. So when you go through your SURF UK assessment, you can look at which of the SDGs are relevant for that particular indicator or category. That answer?
Okay, great.
Yes, so they could easily be linked to the sustainable, to the framework, yeah.
Good, okay. So a second one is, does risk assessment impact on the site's future development proposals? And if so, how? I guess that's sort of how can sustainable risk assessment inform early stages of development proposals?
It's a good question. Yeah, I think a lot of our projects are, this is the development layout and you derive your remedial targets for that development layout. But one way you could do it would be to do the risk assessment before you have any set plans, and then you could use the risk assessment to inform how you're going to redevelop the site. So if you've got contamination in one particular area, for example, you might decide to put your car park there rather than a residential garden, for example. So you could use it that way.
Yeah, saving money as well, I guess.
Save you money, yeah, save you remediation. I mean, yeah, you might have to rethink your development plans, but ultimately it might make the development more sustainable.
Okay. How does the SURF UK framework relate to the LCRM, which for those who don't know is the Land Contamination Risk Management Framework?
So the LCRM, it has guidance on remedial options appraisals, and there's a lot more emphasis now in LCRM for sustainable development, and it actually it signposts SURF UK in it. It recommends incorporating sustainability into the remedial options appraisal and its signpost Surf UK. And I would also say that on the steering group, we have 2 members of the Environment Agency on the steering group. So yeah, so they're involved in it, and it's
they're on board with it. Yeah,
they're on board with it. Yeah.
Well, another one about money actually. Can this methodology be economic on small sites, or does it only relate to larger sites?
No, I mean, small sites can have some really big contamination issues. It doesn't necessarily depend on the size of the site. I mean, risk assessment, I had a site in Letchworth, which was a small site. It was a polishing and plating works, and it had been identified by the Environment Agency as potentially knocking out a public supply well. We did DQRA, the client had limited funds, but we did quite a lot. We did a lot at the conceptualisation stage, which fed into the DQRA. And then ultimately, because we had lots of site-specific information, we were able to prove that they weren't responsible for knocking out the supply well. And therefore, the remedial options after that, they didn't have to do any remediation for groundwater. They still had to put in a vapour barrier for human health. But I mean, that saved the client hundreds of thousands of pounds just by spending a bit more on the DQRA and getting the right site-specific data.
Okay, great. We've got one more. You mentioned the Environment Agency just now, but when should you engage with regulators and other stakeholders, and what are the benefits of doing so? Yeah,
that's a good question, because often, I mean, if it's going through planning, you'll be liaising with the local authority and the Environment Agency. If you're looking to do a surf assessment, it can be good to agree upfront with the EA and the local authority how you're going to weight your assessment and which are the most important elements of the assessment. But what tends to happen is that we'll write the assessment and we'll do lots of sensitivity analysis to have different outcomes which represent different stakeholders. It depends how time pressured the Environment Agency are and the local authority are, and whether they can get involved early. But early engagement is always better.
Okay, lovely. Well, I seem to be out of questions, so well done for answering those. So I'd just like to say thank you, everybody. We've had well over 100 attendees, so thank you very much for coming on and listening to Vivian. Remember, we'll send out the feedback survey, which you should get about an hour from now. The next topic some of you may have seen in our Down to Earth series is about service avoidance for site investigation, so health and safety, really, on the PAS 128 surveys. So hopefully you can all join us, and you should all get another invite in a few weeks' time. Thank you very much. And we'll say good afternoon. Enjoy the rest of your day. Thank you.